welcome again to another segment of post-theory series in Afit. This is Afit Physics post-theory questions, and here with me are some questions I would love us to go in depth in and see one or two things about it. Let's move. Question 1 says a ball is thrown up into the air at the highest point of its trajectory. The ball dash A is accelerating downward, B has zero acceleration, C is accelerating upward, and D double. The answer is A, accelerating downward. Why? Because at the highest point, the velocity becomes zero for an instant, but acceleration is still acting downward, and G is equal to 9.8 meters per second squared due to gravity. So the correct statement is it is accelerating downward. Question 2. A ball of mass 200 grams moving with a velocity of 8 meters per second squared, 8 meters per second, collides and sticks with another ball of mass 300 grams moving in the same direction with velocity 4 meters per second. What is the common velocity after the collision? Yeah. Well, what principle are we using here? We are using principle of conservation of momentum, and this is the formula. This is the formula. M1U1 plus M2U2 is equal to M1 plus M2 into V, principle of conservation. And remember, in previous videos, I always talk about writing your parameters out. So these are the parameters given this. So now, remember, it was 200 grams in the question, and you don't solve in grams. You solve in what? In kilograms. So that's why I converted this mass to kg. So 200 divided by 1000 will give you 0.2 kg. And this also will give you 0.3 once you do it respectively. So you impute it, this is your M1, this is your M2, sorry, U1, this is your M2, and this is your U2. And you are going to solve the masses here at the right hand side. 0.2 plus 0.3, that's why I did here, and then the V. So 0.2 times 8 you get 1.6, and this 1.2. And you have 0.5 V there. So 1.6 plus 1.2 will give you 2.8, and this is 0.5. So what do? This is an equation. You divide both sides by the coefficient of V. And what's the coefficient of V? 0.5. So 2.8 divided by 0.5 is this. This cancels this, and V is equal to 5.6 meters per second. Option A. And question 3 says a boy boils a ball in the horizontal circle. If the cord breaks, in what direction will the ball move? The answer is C, in the direction of the tangent to the circle. Why? Because when the string breaks, centripetal force disappears and the ball moves in a straight line, tangent to the circle at that point, which obeys what? Newton's first law of motion. So, question 4. Question 4 says a force of 20 Newton applied parallel to a horizontal table is just enough to make a 4 kg block start moving. Find the acceleration when the force is doubled. When the force is doubled. Okay, so I'm going to solve this. So we first find the limiting friction. Question 4. For the limiting friction, F limiting F friction is equal to 20 Newton. And N is equal to mass times gravity, which is equal to 4 times 10, which is equal to 40 Newton. So we are going to define the limiting coefficient of friction mu by mu is equal to F over N. We have our F, we have our N, so our mu coefficient is going to be 20 over 40, which is equal to 0.5. So we have gotten our friction coefficient. Then we move to when the force is doubled. Recall that the force applied is equal to 40 Newton. And mu N, that's F, is equal to 20. Is equal to 20. Yeah, mu N. That is this mu. Yeah, remember mu is 0.5 times this N, 40. You have 20, so it's 20. And net force is equal to the force applied minus this. So it's equal to 40 minus 20, which is equal to 20 Newton. So to compute the acceleration, the net force F net is equal to ma, mass times acceleration. So we are using this F net force. F net force is equal to 20. So now remember we are finding the acceleration. So A will be equal to F over N, which is equal to 20. And remember the mass was 4 divided by 4. So acceleration is equal to 5 meter per second squared. You have gotten that, and option what is that? Okay, 5 meter per second squared. So move to the next question. Question 5. Question 5 says a man walks 1 kilometer due east, then 1 kilometer due north. Find its displacement. Find its displacement. So they said draw out our cardinal point. Recall this is north, south, west, east. So you are dealing with north and east. So they say 1 kilometer due east and 1 kilometer due north. So displacement, to find the displacement of this, displacement is equal to, let's call this our A, call this B, call this C. It's going to be the square root of A squared plus B squared. And what's our A squared? It's going to square root of 1 squared plus 1 squared is equal to square root of 1 plus 1. Remember 1 squared is 1 and 1 squared is 1. Equal to root 2. So that's the displacement. The 2 kilometer. Remember. So question 6. A motor car moves with velocity 20 meters per second on a rough horizontal road and covers a displacement of 50 meters before stopping. Find the coefficient of dynamic friction. Given that your G, acceleration of gravity, is 10 meters per second squared. So remember, given, we'll write out our parameters. Given that the initial velocity U that they gave us is 20 meters per second, and the final velocity is 0, and the displacement S is 50. And we are going to use Newton's third law of third equation, Newton's third equation of motion. So what's third equation of motion? V squared is equal to U squared plus 2AX. That is it. So your V 0 squared is equal to U squared is 20 squared plus 2AS. You are using this because you want to get something. Actually, this is not the final answer, so just watch as it goes. 2A, you want to find A and S, 50 times 50. So this is 0 is equal to 400 plus 100A. Yeah, so you collect like this, minus 400 is equal to 100A. You divide both sides by 100 so that A will remain on its own. This cancels this. A is equal to minus 4 meter per second squared. This was a deceleration since we are having negative. So friction provides deceleration, like I said earlier. So to find the dynamic resisting coefficient is going to be mu G. So mu G is equal to 4. Yeah. So mu now be equal to 4 divided by G. Yeah, that negative disappears. So it becomes 4 alone. So the coefficient is equal to 4 over, remember G is 10. When it's also assume So the coefficient is equal to 0.4. Done with that. Question 7 says a physics student is standing on a cliff, throws a stone vertically downward with initial speed of 10 meters per second. If it is traveling at 30 meters per second just before hitting the ground, find the height of the cliff. Assume g to be 10 meters per second squared. So we are still going to be using multiplication operation. V squared is equal to u squared plus 2gh. Different formula. So what's our v? Our v is 30 meters per second. What's the u? U is 10 initial. 10 meters per second. G said we should assume to be 10 meters per second squared. We are finding the height of the cliff, so we don't know. So what are we going to put? Okay, that's all. So now we substitute 30 squared is equal to 10 squared plus 2 times 10 times h. So this is 900. 30 squared is 900, and this is 100 plus 20h. So you connect items. 900 minus 100 will give you 800 is equal to 20h. You divide both sides by 20. Divide both sides by 20. This cancels this cancels this. 2 here 1, 2 here 4. So your h is equal to 40 meters. That is your answer. Question 8 says a quantity is defined as the product of the cross-sectional area and change in momentum per unit length. What is the SI unit? What is it saying? That the product of cross-sectional area and change in momentum per unit length. It's asking us for the SI unit. So, looking at this kg times m all over s. Yeah, kg times m over s. That is the unit is telling us, they are telling us about kg ms minus 1. So, looking at it, this is already trying to tell me that it should look like momentum. So let's check, let's try and see if momentum is really it. So momentum is equal to what? Mass times velocity. Mass times velocity. That is momentum. And now, area has meters squared, but here it's per unit length. So area times momentum over length as unit. So now mass is kg and velocity grams meter per second. Or you can choose to say kg ms minus 1, and this is the same thing. If you want to know more about this, you can check on my previous videos about dimensional analysis, their quantities and their units themselves. You get that there. So question 9. Question 9 says a rectangular concrete block 40 cm by 30 cm by 60 cm and mass 10 kg. What is the minimum pressure it can exert on the horizontal surface? What is the minimum pressure it can exert on the horizontal surface? So minimum pressure occurs when area is largest. Block lying on largest face is 60 by 40. For largest block, they give us 40 by 30 by 60. So the one line of the largest face is this and this. So 60 by 40. And force is equal to mass times gravity. Force is mass times gravity. F is equal to mg. And which is equal to 10 times 1.8. I assume that, and is equal to what? Is equal to 98 Newton. Remember, it gave us mass to be 10 kg in the question, and we assume acceleration due to gravity by ourselves. That's what gave us this. So now I will get our area, the area. Remember, we said minimum pressure occurs when the area is largest. That is why we are now getting this, and this will be our area. Like this was the block. Let's say this was the block. Block. And this was the 60. This is the 40, and this is the 30. So it lies on this place. This is where the maximum minimum pressure exacts at this place, minimum pressure here. So we are now finding the area like this 60 and 40. So area, but we are going to convert it to meters. Remember, since it's in centimeters, so we work in the standard unit. So 40 divided by 100 will give you 0.4 times 0.6, which is equal to 0.24 meters squared. And the pressure P is equal to F over A. P is equal to F over A, force over area, pressure. So now it's equal to, what is the force? The force is 90. 90 and the area is 0.24. It's equal to what? In the calculator. 90 divided by 0.24 is equal to 370. 375. Sorry, it's 98. 98. Sorry for that. Divided by 0.24. It give you 408. 408.33 Newton per meter squared. Always remember your unit. You might get the answer correctly sometimes, but your unit might be wrong and you have failed the question. So be careful. And also, always use calculator to confirm your answer. The lapses I did it. Please, it can happen to anyone. Question 10. Question 10. Question 10 says the simple hydrometer. What happens to its mass and density as it rises? Okay. A hydrometer is a solid body. Its mass and density do not change when it floats higher or lower. What changes is how much liquid it displaces. So the correct statement is mass constant and density constant. That's what changes. That's what happens. Mass constant and density constant. Yeah. So question 11. 11 says stone dropped into a dry well, hit bottom in 2.27 minutes. Sorry. Question 11. A stone which is dropped into a dry well hits the bottom in 2.2 seconds. How deep is the well? Take your G to be 10 meters per second. Okay, so I'm going to use this second equation of motion. X is equal to 1 over 2 t squared. And remember our G is equal to 10. So S is equal to 1 over 2 times G 10 times T. T is 2.2. 2.2 squared. So S is equal to 1 over 2 times 10 times what is 2.2 squared? 2.2 squared is equal to 4.84. So this cancels this is 5. So our distance is equal to 24.2. 4.2 meters. Question 12. Question 12 says A woman whose mass is 70 kg, M is equal to 70 kg. Sits 2.4 meters from the fulcrum of a seesaw. 2.4. At what distance from the fulcrum should a 60 kg man sit to balance the seesaw? Okay, 60 kg. So they said at what distance? At what distance should this man sit? At what distance should he sit? So a simple question. So M1 times S1 is equal to M2 times S2. So an M1 times S1 is equal to 70 times 2.4, and M2 times S2 is 60 times X. So 70 times 2.4 is what? 70 times 2.4 is 168. 168 is equal to 60x. X is equal to 168 divided by 60. X is equal to what? Divided by 60. 2.8. So we should sit at 2.8 meters aside. When it sits 2.8 meters aside, then there will be no casualty. There will be no calamity. So, question 13. Oh my God. Oh my God. Question 13 says that an air bubble trapped at a depth in a liquid rises to the surface. Which of the following is true about its mass and density as it rises? A. Its mass and density increase. B. Its mass is constant while its density decrease. C. Its mass and density is constant. D. Its mass is constant while its density increase. The answer is B. Mass constant and density increase. As the bubble rises, the external pressure decreases. So the bubble expands, so its volume increases. Mass of the trapped air stays essentially constant. Therefore, the density of the bubble decreases when the mass remains constant. So that's question 13. So question 14 says, compute the following sentence. The operation of the hydraulic jack is an application of what? Pascal principle. That's the answer. Pascal principle. And it works by transmitting pressure through a confined fluid. That's what Pascal principle does. That's all, like more the application of it. Question 15. Complete the following statement. Today, the standard meter is defined in terms of A. Distance from Earth's equator to North Pole. B. Wavelength of light emitted from a krypton atom. C. The wavelength of light emitted from. Okay, so question 15 says, question 15, complete the following statement. Today, the standard meter is defined in terms of dash. A. The distance from the Earth's equator to the North Pole. B. The wavelength of light emitted from a krypton atom. C. The wavelength of light emitted from a sodium atom. And D. The speed of light. The answer is the speed of light. Today, the meter is defined in terms of the speed of light. Distance travels in this is question 15. Travels in 1 over 299 792 458 over second. What's this number? This is 100, this is 1000, 299 million. So that is we can say 3 times 10. This is 1 2 3 4 5 6 7 8. You can say let's do this. 1 divided by 3 times 10. Yep. Nine. yeah, 3.34 times 10 raised to power minus 9. So that's it. So question 16. Question 16 says convert 30 meter per second to centimeter per minute. Okay, sharp. 30 meter per second to centimeter per minute. 30 meter per second to centimeter per minute. So 30 meter per second is equal to 30 times 100. 100. So that is equal to 3000 centimeter per second. So per minute, we are doing it like we are breaking it down. So that's it. So per minute now is equal to 3000 times 60 is equal to 180,000 centimeter per minute. So question 17 says during a football match, player A kicks the ball 40 meters 30 degrees east of south to player B, who instantly kicks it 30 meters 60 degrees east of north. What is the magnitude of the resultant of the ball? What is the magnitude of the resultant of the ball? Now they said player A is 40 meters 40 meters at 30 degrees east of south, and XA, the distance A is equal to 40 sine 30 degrees, which is equal to 20 meters, and distance B is equal to, sorry, the Y component of A is equal to 40 minus 40 cos 30 degrees, which is equal to minus 34.641. Player B, this is for B, 30 meters at 60 degrees east of north. So what do we have? The x component of B is equal to 30 sine 60 degrees, which is equal to 15 meters, and the y component of B is equal to 30 cos 60 degrees, which is equal to, sorry, this is 25 25.98 meters, and this is 15 meters. So we are going to sum it, like we sum the x component and the y component together. So xa plus xb is equal to, what's xa? 20, and xb is 25.98, which is equal to 45.98 meters. Ya plus yb is equal to minus 34.64 plus 15. So that will give you minus 19.64 meters. So we're going to take the resultant. Remember, they asked us to find the resultant displacement. So r is equal to the square root of x squared plus y squared. That means we're going to square this and this and this. So is equal to, r is equal to the square root
45.98 squared plus minus 19.64 squared. So r is equal to what? The square root of, let's calculate this, 45.98 squared is equal to 2114.16 plus minus 19.64 squared. Careful, you have 385.73. So getting the resultant, then the resultant r will be equal to the square root of 2114.16 plus 385.73 is equal to this. So it's going to be square root of 2499.89, and r is equal to 49.99 meters, and approximately equal to 50 meters. So if 50 meters is there, the answer is 50 meters. Option C. Question 18. Question 18 says, how much work is done against gravity in sliding a 500 grams object through 2 meters up a smooth plane that is inclined at 30 degrees to the horizontal? Okay, so how's this going? Work done in sliding. Remember, they gave 500 grams. So what are you going to do? You convert it to kilogram, and 500 grams to kilogram will give you what? M will be equal to 0.5 kg. So an object 2 meter smooth plane inclined at 30 degrees. So the theta is equal to 30 degrees. Your S is equal to 2 meters. So vertical rise, that is your vertical component. I think we did that here. Yeah, vertical and horizontal component. So vertical rise is equal to 2 sine 30 degrees, which is equal to 2 sine 30 is 0.5. 2 times 0.5 is equal to 1 meters. That is, it rose at 1 meters. So work done against gravity, work done. So what's work done? Work done, W is equal to mass times gravity times height. So we have our mass, we have gravity to be 9.8, and this is the height, vertical. Remember, this is vertical and this is horizontal, VH. So sine. So in this component, this is y and this is x. So in this component, you deal with sine, and in this component, you deal with cos. That is why we use sine. It's not like I can use cos, so no. Cos, if you use cos, you will not get it. So, but since they say vertical, assuming it's in the horizontal component, then you're using cos. So this is vertical, so you are using sine. MGH. So work done, and let's find our work done. Mass is what? 0.5. Remember to convert this to kilogram. Or even if you get the final answer, then convert it to kilogram to be safe. And the G is what? 9.8, and H is 1. So what is our work done? Calculating 0.5 times 9.8 times 1 is equal to what? 4.9 joules. 4.9 joules. 4.9 joules is D, option D. So that's correct. That's question 18. D, 4.9 joules. Question 19. If a small body of mass m is moving with angular velocity in a circle of radius r What is its kinetic energy? What is its kinetic energy? Kinetic energy of mass m moving in a circle of radius r with angular speed. Linear speed, linear speed, linear speed v is equal to angular speed times radius, and kinetic energy k is equal to half mv squared, which is equal to what? Half times m. Remember you said linear speed here, v is wr, so you substitute it here. And this is not normal w, it's angular speed, wr squared. So finally k will be equal to 1/2 m angular speed squared and radius squared. If you see this, then that is the answer, and I think you find that in option C. Option C. Sorry. Yeah, option C. So question 20. Move to 20. Excuse me. Question 20. Question 20 says, what does it say? It says in a free fall, two balls of mass 20 kg and 10 kg were dropped from a height. If the ball with a smaller mass reached the ground after 4 seconds, what is the difference between the time the two balls reach the ground? What is the difference between the time the two balls reach the ground? So in free fall, all bodies accelerate at the same rate. Yeah, all bodies accelerate at the same rate. If both are dropped from the same height, they hit the ground at the same time. Yeah, irregardless of their mass. If they drop from, let's say, 20 meters, they reach the ground the same time. So the time difference will be what? Definitely it's going to be 0 seconds. It's going to be 0 seconds. I wish I can do a practical here, but just assume this and this is actually different mass. So now the same height, it reaches the same. So the time difference between both of them is 0 seconds. So that's the practical for that question. So the answer is 0 seconds. 0 seconds. So what option is that? That is option C. So we move to 21. In what distance can a 1500 kg automobile be stopped if the brake is applied when the speed c is 20 meters per second and the coefficient of sliding friction is 0.7 between the tire and the ground? Okay, let's go into this. Question 23 says 3 vector a, b and c add together to yield 0. A plus b plus c is equal to 0. The vector a and c point in b opposite directions and their magnitude are related by the expression a is equal to 2c. Which of the following conclusions is correct? A and b have equal magnitude and point in opposite direction. B and c have equal magnitude and point in the same direction. C, b and c have equal magnitude and point in opposite direction. D, a and b point in same direction but a has twice the magnitude of b. So what do we think is going to be the answer? The answer is b, but let's solve and see. From a plus b plus c is equal to 0. Substitute a is equal to 2c. What do you have? You're going to have 2c plus b plus c is equal to 0. So b plus 3c is equal to 0 and b is equal to minus 3c. So b and c point in opposite directions and is equal to 3 absolute value of c. This matches the choice b and c have equal magnitude and point in opposite direction. The correct statement is b and c point in opposite direction and the magnitude b is 3 times that of c, 3 times that of c, but they point in opposite direction. When you will find out in the answers, 23 direction choice. Actually, what it's in the options is somehow close to, but it's not it. So this is the correct, in case maybe you see it in your CBT on that day, they might have affected it, but this is the correct this thing. It what in the answer here is absolute value of b is equal to direction of c like this, but this is the correct this thing. You see through the solving there. Okay, so question 24. Question 24 says, which of the following could be measured sorry, in the same unit as force? A. Energy over distance. B. Energy times distance. C. Energy over time. And D. Momentum over distance. So force has units. So force N is equal to joule per meter. So and energy is measured in joules and distance is measured in meters. So I think option A is in line with us. So I think we should pick energy over distance. So that is the answer. 25. Which 25 says, which of the following does not affect the pressure at a point beneath the surface of a liquid? A. Surface area of the liquid. B. Density of the liquid. C. Depth of the point below the surface. D. Strength of the gravitational field. The answer is A. How? And let's do it. Pressure at depth h is equal to rho g h. It depends on density, gravity and depth. Density, gravity and depth. It does not depend on surface area. So this is density, this is gravity and this is depth. And in the question they said surface area, density, depth and strength of gravitational field. Strength of gravitational field, depth and density. So surface area is not among these three for pressure. So you take A as the answer since it's the odd one among the four options. 26 says, which of the following pairs contains one vector and one scalar quantity? A. Displacement and acceleration. B. Force and kinetic energy. C. Momentum and velocity. D. Power and speed. So I think checking the pairs, displacement and acceleration, they are both what? They are both vectors, they are vector quantities. Momentum and velocity are both vector quantities. Momentum, acceleration are both vectors also. So but the one that is one vector and one scalar is what? Force and kinetic. Force is vector and kinetic energy is scalar quantity. So option B goes for that. Question 27 says, which of the following statement is correct? A. Uniform speed always implies uniform velocity. B. Uniform speed always implies zero acceleration. C. Uniform speed may imply non-zero acceleration. D. Constant momentum implies constant acceleration. What goes with this is C. Yeah, because uniform speed can occur with changing directions. That's uniform circular motion. So uniform speed does not always imply uniform velocity. And uniform velocity, constant vector, means acceleration is equal to what? Zero. So the true statement is uniform velocity implies zero acceleration. And the answer there is 6. And we move. 28. 28 says, which of the following measurement was taken with vernier calipers? Vernier caliper, you know, for measurement devices, due to their like the maximum of range it can go, so a vernier caliper might not be able to measure what a micrometer screw gauge can be able to measure. So they all have ranges. So let's look at the options. A 2 centimeter, B 2.00 centimeter, C 2.000 centimeter, and D 2.0000 centimeter. Here now what he's trying to talk about is maybe um the how do I put it, let's say like the error it can make, like the if you are approximating it in like in decimal places. So but like the maximum you can find, let's say like this is vernier caliper, this is an example of a vernier caliper. um let's say this is 5, 10, then it comes here like this, comes here like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 5, 6. Okay. 1, 2, 6, 7, 7, 8, 9, 10. So 11. So and let's call this 5. So this is in centimeter and this is in millimeter. You get? So how many millimeter makes a centimeter? 10 millimeter. So that is where it's having its point 0 0 from. You get? So now this is, what do we call this? This is 10.1. Then from here, point 1, 1 what? So you look for where this slips in with. This is the vernier scale. This is the main scale, sorry, main scale, and this is the vernier scale. So let's look for, this is 10.05, 06, 07, 08, 09, 1, 6. Okay, so let's make this 0 and 1. So you see it enters in this place. So this is 10.1, 1 what? 0.01, so 10.11. So it's like, you get what I'm saying? So question 29. Question 29. Question 29 says, which of the units of the following physical quantities are derived? 1. Area. 2. Thrust. C. Pressure. 4. Mass. A. 1, 2, 3 and 4. B. 1, 2 and 3 only. C. 1, 2 and 4. And D. 1 and 2 only. He said, which of the following physical quantities are derived? Now you know we have fundamental quantities and we have derived quantities. So listing them out, let me list it out. Area, thrust, pressure, and what? Mass. So derived quantities. So um derived quantities here. What are derived quantities from the beginning? These are quantities that are they are like due to combination of maybe 2 or 3 fundamental quantities. You now have derived quantities. And area did not just come on its own. Area is length times length, like, so you have multiplied 2 fundamental quantities. So that means you derived area be that. So area is derived. Thrust, the same thing. Thrust is not among the fundamental quantities. So this pressure earlier here, remember, density, gravity and height, fundamental quantities, you multiply them together. or you for yeah, that's for pressure. So you get that. So that's derived, we derived it. And mass is on its own. We all know mass and the unit kg. So this is not a derived quantity. So this and this are derived quantities. So the answer is 1, 2 and 3. 30. Which one of the following situations is not possible? A body has zero velocity and a non-zero acceleration. B, a body travels with a northward velocity and a northward acceleration. C, a body travels with a constant velocity and a time varying acceleration. And D, a body travels with a constant acceleration and a time varying velocity. The answer is C, a body travels with a constant velocity and a time varying acceleration. If you ask me how, okay, how is if acceleration varies, velocity must change. So it's not possible. So question 31. If C 31. If C is the thermal capacity of a material of mass m and S is the specific heat, then A S over m, B S is equal to Cm, C is equal to Sm, D Ds is equal to Ms. So how do we solve this question? By definition, thermal capacity C is equal to Ms and C is equal to Sm. That's the answer. C. Option C. So that's that. Question 32. Question 32. Question 32. Okay. We are moving. So question 32 says a black car can be more uncomfortably hot on a warm day than a white car because A, it is hot on a warm day. B, it is black. A black object is better absorber of heat. C, black cars have heater installed in them. D, white cars have air condition installed in them. So looking at these options, we will know that the answer is B. And why? Because a black object is better absorber of heat. See, that's why most times it's advisable to like black than white. Black absorbs is a better absorber of heat. So it makes the vehicle to be like more uncomfortable, you understand, it absorbs. And the other ones like maybe white, it feels the opposite. So question 33. A little sag is left in overhead telephone wires. Why? A, because tout wires do not conduct sound easily. B, to allow for the effect of a rise in temperature due to heating effect of current flowing through them. C, to allow for the effect of a rise in temperature of the surrounding atmosphere. D, to allow for the effect of fall in temperature for the surrounding atmosphere. This is a temperature related question, and you have done all these stuffs. If you remember, is done to allow for the effect of fall in temperature of the surrounding, to allow for contraction when temperature falls, like when temperature falls, contraction. So that's 33. So question 34. A piece of copper wire of length 100 centimeter at 30 degrees Celsius is heated to 120 degrees Celsius. If its linear expansivity is minus 41.8 times 10 per k, its new length is what? This is linear expansivity. Linear expansivity. Okay, linear expansivity. So copper wire change. Length at 30 degrees Celsius is equal to 100 centimeters. Okay, 34. Equal to 100 centimeters. Heated to heated to 120. So I think L1 is equal to 10. Sorry, T1 is 30 degrees, T2 is equal to 120 degrees Celsius. Yeah. So change in T is equal to 90 degrees, and you say take the linear expansivity to be equal to 41.8 times 10 raised to power minus 6 K per Kelvin. And okay, so the new length now will be equal to, this is the formula now, L1 bracket 1 plus alpha change in T, yeah, this is it. So and it's equal to, what's our L1? L1 100 into 1 plus wetin be what alpha 41.8 times 10 raised to power minus 6 times 90. Yep. So the new length is equal to what? 100 into 1 plus, remember your board mass rule still applies here, so be careful. 41.8 times 10 raised to power minus 6 times 90 is equal to 3.762 times 10 raised to power minus 3. So it's equal to what? 100 times 1.003762. Yep. So it's equal to what times 100? What do you have? You have 100.3762 centimeters. Yeah, 100.37, or you can say L is equal to 100.4 centimeter approximately. So that's the new length. Then if you want to find change in length, L2 minus L1, which will give you that 100.4, but it seems like it's not in the option, but this is the nearest one. Yeah, this is the nearest this is the nearest answer. Yeah, the nearest answer. So question 35. What does it say? A sample of a monoatomic ideal gas is originally at 20 degrees. What is the final temperature of the gas if both the pressure and volume are doubled? If both the pressure and volume are doubled. So initial T is equal to 20 degrees. Yeah. And converting this to Kelvin, what do you have? Tk is equal to 200 and what? 93 Kelvin. So, and we all know that PV is equal to nRT, ideal gas. Remember, ideal gas. So finally, to find T2 will be equal to P2 V2 over P1 V1 times T1 times T1. So this Tk is your T1. Find the second temperature. So T2 is equal to, what is P2? Okay, Doing that, you have 2 times 2 times 293. T2 is equal to 4 times 293. And what is 4 times 293? 1172. Remember, it's in K. If they ask you to convert to back to degrees Celsius, you just subtract 273 from it and minus 273, you have 899 degrees Celsius. That's the final answer. I think option C is corresponding with our so remember why we said 2 times 2, remember it was doubled, that is why. So question 36. Question 36. Yes, sir. Question 36 says a volatile liquid used for cooling purpose in refrigerator is what? A. Liquid ammonia. B. Cold water. C. Liquid nitrogen. And D. Liquid helium. You all know that. I think from chemistry, it's liquid ammonia. Liquid NH3. It's what is used. It's what is used for cooling purpose in refrigerator. So we'll move straight to question 37. 37. What does it say? Complete the following statement. A temperature decrease of 30 degrees Celsius is equal to a temperature decrease of what? A. 30 degrees Fahrenheit. B. 17 degrees Fahrenheit. C. 30 degrees Kelvin. And D. 86 degrees Fahrenheit. So we'll apply our temperature conversion formulas in this place, because that Kelvin is not possible because you are adding 273, so it has passed, so it should be within those degrees Celsius and degrees Fahrenheit. So let's do trial by error now and see. So Fahrenheit conversion to Celsius is equal to whatever you get degrees Celsius times 9/5. Yeah, and they said it's 30, so this is 30 times 9/5. 5 here 1, 5 here 6, 6 times 9, 54 degrees Fahrenheit. Is that what is there? Let's check. 37. No, that is not what is there. It's not there. So we're going to try. The key says 86 degrees Fahrenheit. That means they assume 30K in difference in absolute term. No, 30 degrees change equals 54 degrees. Not 86 degrees Fahrenheit. The 86 degrees Fahrenheit corresponds to 30 degrees Celsius plus 32, which is incorrect for a change. Complete the following statement. Bimetallic strips are used as adjustable switches in electric appliances. Consist of metal strips that must have different dash. A. Mass. B. Volume. C. Length. D. Expansion coefficient. The answer is expansion coefficient. It operates by bending when temperature changes to allow for the effect of a rise in temperature of surrounding. That is that. D. We move. 89 says heat can be transferred from one end of a metal rod in contact with it to the other end, which is in contact with it through what? Through conduction. Heat transfer in physics, conduction. So that's a walk-away question. So question 40. Heat supply or removed from a system which causes a change of state without a change in what? The answer is latent heat. Latent heat is the answer, without a change. So that's 40, latent heat. Question 41. How many atmosphere of pressure must a liter of gas initially at a pressure of 1 atmosphere and temperature minus 20 degrees Celsius be after it has been compressed to half liter at 40 degrees Celsius? Okay, so we use assumption ideal gas. So P1 V1 over T1, P1 V1 over T1 is equal to what? P2 V2 over T2. So and they said T1 is equal to minus 20. Remember, convert to Kelvin. Minus 20 degrees Celsius plus 273 will give you 253 Kelvin. Okay, and T2 is equal to 40 degrees Celsius plus 273. What does it give you? 313 Kelvin. Okay, so then we have gotten our T1, T2, and so P2 is equal to P1 times V1 T2 over V2 T1, which is equal to 1. Remember the initial pressure 1 atmosphere, so that is 1 times the V1 over T over V2 is 1 over 0.5, and T1 over T2 is what? 253 over 313. So what do we have here? 1 over 0.5 is 2 times this. 253 over 313 is equal to 0.8083, and your pressure is equal to what? 1 point. Sorry, I made a mistake. This is 313 over 253. 313. Please be careful. Be careful. And unfortunately, you can even see this mistake as an answer. So just be careful. 313 divided by 253 times 1.2372 times 2. What do you have? 2.47 atmosphere. Yeah. Question 42. Question 42 says, on a cold day, a good conductor X feels colder to the touch than a poor conductor Y because A. Y retains more heat than X. B. The temperature of X is lower than that of Y. C. X conducts heat from the body less rapidly than Y. D. X transfers heat from the body more rapidly than Y. So what do you think is the answer? The answer should be D. Yeah, because a good thermal conductor removes heat from your warm hand more quickly than a poor conductor. So it feels colder even if both are the same temperature. So move to the next question. The boiling point of water does not depend on A. Impurity in water, B. The external pressure, C. The quantity of water, and D. All of the above. We all know that it depends on the impurity. If there is impurity inside, then it might not boil at a standard temperature 100 degree, and it also depends on external temperature. Me boiling water at this floor in Afit here compared to someone boiling water in Kilimanjaro mountain, that one is tend to boil faster. Why? Because of the pressure. There is low and here is high, so the difference there. So the quantity of water, quantity of water does not depend. It does not depend. I can be boiling 20 liters of water and this one is boiling 10 liters of water. So far as no impurity is found in both of them are supposed to boil at the same temperature. All of the above is not the answer. So the answer is what? C. So question 44. The ice and steam points of a local liquid in glass thermometer are 10A and 90A respectively. What will the thermometer read when the temperature is 30 degree? Is 30 degree and steam point. Okay, so R is equal to L plus V minus L over 100 times Tc. So L is equal to 10 and sorry, not V, U is equal to 90. So is equal to 10. You substitute plus 90 minus 10 over 100 times Tc is 30. So this is equal to 10 plus 80 over 100 times 30. This and this. So is equal to 10 plus 24 because 8 times 3 gives you 24. So R is equal to 34. 34A, D, option D. So 43. Sorry, 45. This is 44. 45. The lower and upper fixed points of a thermometer are 40 and 120 respectively. Its reading at 60 degrees is what? Question 45. Fixed point. We're still doing fixed point. So, and remember I've given you the formula there. So we just impute it again. 40 plus 80 over 100 times 30 is equal to 40 plus 24 and is equal to what? 64. 64. This one 64. 64. So question 46 says the pressure exerted by a given mass of gas in a container dash A decreases if the container is heated, B increases if the molecule of the gas move faster, C increases if the volume of the container is doubled, D decreases as the kinetic energy of gas molecules increases. The answer is what? The answer is B. It increases if the molecule of the gas moves faster. Why? Because at fixed volume, pressure increases with the average speed of that's kinetic energy of molecules increases when temperature rises. Pressure increases with temperature at constant volume. Question 47. So the answer is what do we say is the answer? The answer is B. Sorry, marker. B. Question 47. Question 47. The temperature in an electric iron is regulated by what? A. Thermometer, B. Bimetallic strip, C. Steel, and D. Conductor. We all know for iron is what? Bimetallic strip. Yeah, strip, anyone. 47. Okay, B. 48. Water has an anomalous behavior between 0 degree and 4 degrees Celsius. Which of the following is correct? A. Mass of water increases between 0 degree and 4 degree. B. Density of water decreases between 0 degree and 4 degree. C. Volume of water increases between 0 and 4. D. Volume of water decreases between 0 and 4 degrees. It actually decreases and forms ice. So the volume reduces. So the answer is D. The answer is D. Okay. 49 says, what is the Celsius equivalent of 50 degrees Fahrenheit? What is the Celsius equivalent of 50 degrees Fahrenheit? Let's clean this place. So want to convert to Celsius is equal to what? Cf minus 32 times 5/9. So and they gave us 50 degrees Fahrenheit. 50 degrees Fahrenheit to degrees Celsius. So and this is 50 minus 32 times 5/9. So this is going to be equal to 18 times 5/9. If you do your calculation well, 9 here 1, 9 here 2. 2 times 5 is what? 10. 10 degrees Fahrenheit. 10 degrees Fahrenheit. There are actually some shortcuts you can have used with this, but should I say unfortunately in Afit this calculator is not allowed. So I will advise you to learn the formula by yourself so that you will not get confused in the exam. Question 50 says, when water is heated in a glass vessel, the level first falls and then rises because A. The apparent expansion of the water is initially small and later increases. B. There is anonymous expansion of water. C. The glass vessel does not expand. D. Glass vessel expand first before water starts a more rapid expansion. The answer is D. Why? Because the glass vessel expands first before the water starts a more rapid expansion. The glass expands slightly on heating, lowering the water level initially. As water heats more, it expands faster and then rises. So then rises. That is question 50. And so what's the option? The option is D. So glass vessel expand first before water starts more rapid expansion. 15. D.